Good afternoon, everyone. I'm Abhay from the marketing department of EDS Technologies, and today I'll be your host for this webinar. So, first and foremost, we thank each and every one of you for taking your time out and joining this webinar. We have titled this webinar as Modeling and Simulation of Battery Development and Powertrain for Electric Vehicles. First, I would like to begin the webinar by giving a short introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and also platinum partner to Dassault Systems. We have served more than 2,000 customers across India, and we operate in 9 locations, with our headquarters being at Bangalore. We also have strategic partnerships with world leaders like EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions for automotive industries, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. With respect to EDA solutions, we closely work with Synopsys, and for GIS, we have a partnership with Esri. We have a dedicated sales, support, marketing, and customer satisfaction teams to address customers' PLM business and support requirements. We also have our own e-learning portal, EDST e-learning, which is a web-based training and skill development application with more than 135 CAD and domain-based courses. Coming to the EV industry in particular, we are engaged with multiple EV manufacturers in India. In terms of solutions, we support them for battery engineering, body structure engineering, charging infrastructure, electric powertrain, interior and exterior trims, and electrical wiring harness. In today's webinar, we are joined by two of our industry consultants. Our first speaker is Mr. Sanjeev Mani. He carries an industry experience of more than 3 years in the field of 3D experience simulia, involving technical support and training. At EDS Technologies, he handles the pre and post sales activities in the southern region for the Simulia brand. So, our second speaker is Mr. Srikumar Maganti. He is working as General Manager Technical at EDS Technologies, having more than 20 years of experience in the field of PLM and 3D experience platform, involving technical support, corporate trainings, and CRM. At EDS Technologies, he manages the 3D experience brand across all the locations. He also has various global certifications from Dassault Systems. Over to you, Sanjeev.
So I welcome all the attendees to this webinar. So today the major agenda is we are going to discuss on about the battery management system. So the thermal management system of the batteries. So how the powertrain engineering is implemented. So I'm following the Q&A session. So let us jump into the battery management system. So when it comes to the EV market, to develop the product's life, to improve the product's life and reduce the cost and the time to market of your product. So we are in need of eliminating various constraints and the challenges that are faced by the EV market today, right? From the speed limitations of the e-vehicles. So from the safety aspects, we need to stick to the safety compliances. So along with the battery life management. So all these are the various challenges that are faced by the e-vehicle in the current scenarios. So this requires an unified solution to eliminate all these challenges, so and bring their product to the market in a much greater aspect. Okay. So when it comes to the battery management system, so as the battery is the key component of this structure, so it is necessary to eliminate all these challenges that are faced in the battery level itself. So it may be a thermal problem, the efficiency problem. So it may be the temperature spread durability problems. So everything, there are various challenges that are faced in the industry currently. So usually the industry follows a traditional process wherein it consumes around 35 weeks of time in building the prototype of the battery right from the cell level. So and to assess the characteristics of the cell level, so it is consuming around 35 plus around weeks. So this is the traditional process followed by each and every industry in the market. So to reduce this time consumption, so we are in need to get an unified platform So wherein we can collaborate all our engineering data together and collaborate so to work efficiently. So, so to work efficiently, our 3D experience Simulia so is one of the unified packages for all the engineers. So basically 3D experience Simulia, so it uses the Abacus solver so to solve your simulations. So it is a worldwide proven and tested software which is used by a lot of FE engineers and which is accepted worldwide. So this 3D experience Simulia is a common platform so which can be collaborated by all your stakeholders within your organization. So by considering the multiphysics of your cell of your products, so you can assess the performance of your products right from the cell level. So when your object is subjected to the combined loadings of the well along with the mechanical loadings, so you can also simulate the misuse conditions wherein the abusive scenarios can also be simulated right from the cell level itself. So this kind of combined platform which ensures your multiphysics is provided by the 3D Experience Simulia. So when it comes to the 3D Experience Simulia, so the Abacus GUI is an unified GUI, so wherein it provides a lot of automatic mesh creation tools in your to create your FEM model. So thereby you can create a complex FEM model within a few minutes. So this is a major time reduction tool which is used in the Abacus GUI in the inside 3D Experience Simulia. So you with the help of when it comes to the large assemblies, so with the help of the general contact algorithm, so you can bring in all the external surfaces of your assembly, so to define into the contact domain. So wherein you can place your contact surface properties, so you can define your mechanical contact properties for your each and every parts, so which are going to be interacted during your simulation. So it is a very intuitive user interface, so wherein you can easily access all your boundary conditions of your models, FEM models. So you can easily visible the part geometry along with the mesh geometry. So you can easily differentiate between all those things with a intuitive interface. So when it comes to the user interface, so it is you have an the guided procedure. So wherein you can follow the step-by-step procedure, you will be having an inbuilt assistance in the tool itself. So it will guide you how to take you through the further steps. So what is the next to be defined to simulate your model? So the user assistance will guide you. For the newbies, the user assistance is a great tool to explore in. So when it comes to the post-processing, we have a very good, powerful post-processing visualization module. So wherein you can explore the performance of your cells right from the inner level itself. So we have a powerful visualization module inside the 3D Experience Simulia. So you can always explore your each and every parameters in the greater manner. So when it comes to the whole the element level, so Abacus Simulia 3D Experience Simulia gives you an wide range of family of the element when it comes to both explicit or whatever explicit analysis or implicit analysis, whatever analysis you do. So you always have a broad range of element family. So to have an inbuilt library, you can choose your global element. The global assignment can be very well done inside the assemblies. So you can easily set up your initial conditions. So you can set up your the boundaries and load conditions very well in the inside the GUI. So it is an user friendly GUI, so along with the guided assistance as I mentioned before. So the visual visibility manager also helps you in accessing the various parts of your FPM geometry as well. So when it comes to again the user interface, you can always have the different capabilities of the 3D Experience Simulia. So wherein you have the inbuilt calibration tool, wherein you can calibrate your data and you can evaluate your material behavior inside the Abacus GUI itself. So when it comes to the cell level, as I mentioned before, you can always very well perform all the famous mechanical test. Either it may be an axial compression, the radial compression, or it may be a three-point bending. So along with the impact test. So when it comes to the cell level, you can detailedly study and assess the characteristic of the individual cells. So how it is going to perform under your dynamic loading conditions. You can perform various tests with only a single FEM model itself. So it is a very good advantage of the virtual test setup, so wherein you need not have different geometries and FEM models. With a single geometry, you can combine or you can perform all these various test setups. Okay. So when it comes to the module level, so as I mentioned before, so your assemblies become complex and it becomes more larger. So when it comes to the module and pack level, so when compared to the cell, similar to the cell, you can also perform all these tests, assess the performance of your module and pack level itself. So when it comes to the module and pack level, you can ensure your strength and integrity. So you can subject your product into a mechanical abusive scenarios. So under a rapid scenarios wherein how your internal cells are behaving due to the, and you can ensure your safety measures of your product as well. So when it comes to the whole assembly or module pack level, so you can also assure the thermal management as well. So again, with the whole of the pack module also, you can easily simulate your multiphysics capability inside the 3D experience simulia. Okay. So as I mentioned before, these kind of modules and packs can be assessed within a single virtual setup. You can create n number of scenarios. You can easily simulate both the linear and non-linear conditions of your assembly as well. So you can have your under the static how it product behaves under your static loading or maybe a dynamic. So the model responds to your loading. So within the single virtual environment, you can perform all these tests very well. Okay. So, as I mentioned before, assembly comprises of a lot of components. So your automatically your size of your components will be increased. So always a detailed cell representation may take a huge amount of time. Also, you will be end up in the increasing computational effect of your whole assembly. So it is always better to use the so reduced cell modeling. So which is very well powerfully performed by the 3D experience simulia. So you can always use your cell reduced cell prototyping, so modeling to get your results without any compromisation in the result accuracy. So if you compare your the original degree of freedom, so it is about 50.4 million. So when it is simulated, so you will be end up in a long computational time. So whenever you go for the reduced cell modeling also, so you are nearly achieving the same kind of results without any compromising in the results. Okay. So this kind of when it comes to the huge assemblies, it is always to better to go with the reduced cell modeling. So it is very well captured by the simulia. Okay. So as I mentioned before, for your structure, you can always perform your various code design configurations by the help of the optimization technique. So you can vary your stiffness of your whole assembly. So you can always use the parametric optimization. You can increase your build bead size. You can increase and decrease the width and spacing of your build bead. So when it comes to the pack level or the module level, so it is very much possible to explore your various configurations and various designs. So with the help of this parametric optimization, so you can always explore your various design configurations. You can instantly vary your bead spacings. You can instantly change your curvature of your beads and the length of your beads. So that by shifting your the stiffness properties, that way you can protect your component from the lowest natural frequency. You can shift your frequency range as well. So when it comes to the detailed level of modeling, so you can 3D experience simulia always provides you an most automatic tools where you can reuse the existing FEMs, part level FEMs into your assembly. So thereby you need not spend much time in creating your complex assembly level FEM model. So you can at any point of time you can reuse your existing FEMs. Thereby you can customize your contributed FEMs for your geometry analysis. Okay. So that when if you take your different modules, a two-wheeler can contain only 12 to 14 modules. When it comes to the higher vehicles, it may be consisting up to 400 to 500 cells and modules. So thereby you need to spend a lot of amount of time in detailing detailing the capturing the meshing of your each and every cells in the pack and module level. So by using the reusing technology, you can always customize your FEM creations. So thereby quickly modify your assembly level FEM geometric creations. So thereby saving a lot of time and spending much time in the pre-processing level. So when it comes to the thermal level, so again, you can very well simulate and predict the different airflow conditions within your complete casing. So initial design might be having a few space configurations of the individual cells. So whenever it comes to the airflow predictions, you must be clear in how your temperature distribution plot has been uh, carried out throughout this airflow. So when it comes to the CFD also, so we can have your always an CAD enabled the fluid simulation. So thereby, if you change your CAD geometry in the design stage itself, that design will be instantly replicated in your CFD simulations as well. So there is always a global integrity between, so it is just an one click mesh update. So whenever you globally update your model, so it will automatically predict the changes that are made in the CAD geometry. So those changes will be instantly reflected in your CFD simulations as well. So like this, you can, if you consider this as an initial spacing configuration between each and every cells, at any point of time, you can vary the parameters of the spacing of the cells in between your casing, inside the casing. Always you can change the width and the height of your spacing of your cells. Inside the CFD itself, you can change by using the parametric optimization. So it is a powerful tool, so which helps you to aggressively explore various designs within a short period of time. So if you change your dimensions of your spacing of your cells, and you can quickly regenerate one more configuration, thereby uh, quickly assessing the results, how the air prediction changes, air flow prediction behaves inside these kind of spacings. So which is the best optimized spacing that we can allocate for our complete cell and pack. So as we mentioned before, you can instantly you can verify the results of your various configurations right from the original pack if you see in the left side. So by changing the parameters instantly, you are assessing your various configurations within the single model itself. So and at any point of time, you can be arriving at the best optimized solution with the design of your battery pack. So this CFD enables you to engineers to optimize your configurations very quickly. Okay. So as I mentioned before, the cooling medium can be either the air cooling or it may be a liquid cooling. So both are supported. You can define your the material parameters. So how the temperature distribution is been gradually varying when you use different mediums to cool your systems. So it is very much possible to easily adapt the your changes of your model and along with the changes of the cooling medium itself. So you can instantly vary the result difference in the single platform itself. So when it comes to the safety level, so it is always important to assess our structure's performance when it is subjected to a mechanical abusive scenarios. So how structures strength and stiffness varies. So how the what is the permanent damage happening occurred at the end of the abusive scenarios. So how the reaction forces are varying for each and every single variant of our configurations. We can simulate all these kind of abusive scenarios. So as I mentioned before, you can always perform different criteria for a single model setup. So you can perform a drop test, you can perform a shock test, so you can perform a penetration test. So it can be either maybe a side penetration or a top penetration, or else you can perform a crush test of your complete module and pack. So these kind of abusive testings can be very well be simulated with the help of the general contact algorithm. So you need not spend much time in defining the contact properties for the each and every individual surfaces. So all the external surfaces will be automatically come to considerations when it is pulled to the contact domain. So you can globally specify the interaction properties between all your internal cells. So which gives you an aggressive results within the short period of time. Okay. So this kinds of testings is very much possible when it comes to the safety level analysis. So always you can ensure your product safety under these kind of scenarios. So when it comes to the thermal side, you can always perform your structural thermal analysis as well. So either it can be an steady state thermal analysis, or it can be an the transient analysis. So both are very much possible in this 3D experience similar. So you can easily eliminate the hotspots of your zones. So how to shift your hotspot zone without how to shift your zone in the from the critical zone. So how to increase your life of your cells and the batteries. Easily you can predict using the different kind of setup scenarios. So this kind of always this battery management system and thermal management system can be efficiently performed inside our unified platform. So when it comes to the vehicle integration, the electric drive plays a major role in the vehicle integration part. So either it may be the thermal performance of the electric drive or the mechanical of performance of the electric drive. So when it comes to the electric drive, so it is always important to estimate the lifespan of the electric drive, which is the very most important component of the transmission system. So when it comes to the engineer, so they will be always interested in maximizing the lifespan of your components. So thereby you have to explore various design configurations within a short span of time. So to optimize the best design to survive the different scenarios inside your vehicle. So you can 3D Experience Simulia enables the users to explore various designs quickly and perform the thermal assessments level of your electric drives. Okay. So when it comes to the electric drive, so not only the thermal solutions are possible, you can always perform the noise and vibration solutions. You can have the integrations between all these kind of solutions, electromagnetic solutions, the CFD solutions, strength and stiffness and durability calculations can also be performed for your assessment, for your products assessment. So, and you can continuously have a collaboration between each and every solutions of your product. So you can instantly vary any one of the parameters that will be reflected in every simulation parameters. Okay, so these kind of detailed level of simulations can be done for your electric drives. So when it comes to the strength and stiffness portions of your drives, so when you let us consider a single CAD model, so if you take your gear assembly, so the single CAD model can be used for the various multiphysics analysis. Either it can be an electromagnetic simulation, or it can be an FEM, the structural simulation, or it can be a multi-body simulation. So you are spending only one model. By using this one model, you're creating one single FEM model. So you're using the same model to simulate all these kind of multiphysics, and you can capture you can organize your workflow in a complete manner. So again, when it comes to durability, so 3D Experience Simulia always provides you to perform the durability analysis as well, along with the all the combined multiphysics simulations. So when it comes to gearbox lubrication, so you can very well perform the with the help of the CFD capabilities, you can very well perform the analyzing your internal products, so how it behaves under the different fluid scenarios. So you can always modify your designs quickly and make it adapted within this workflow. So that by you can generate your design exploration assessments in a very quick span of time, right? Generating your quick results. Okay. So next session, let me introduce Mr. Sri Kumar. So to carry forward on the powertrain analysis. So over to you, so Sri Kumar, sir.
Thank you, Sanjeev.
Yes.
Now I'll be taking over on this electric powertrain performances by using multi-physics simulations. So typically, we make use of systems engineering approach here using CATIA systems. Here, we follow through certain process in terms of RFLP approach, which is requirement analysis, functional definition, then followed by logical circuit definition, and then the physical modeling. So we combine all the aspects to see this complete performance of the electric powertrain, the complete multidisciplinary dynamic behavior that we can really assess, and we can take this take all the parameters into consideration and also do this trade-off analysis studies. So basically, this particular solution, I mean, it combines multiple systems. So we have electrical systems and the electronic circuits or mechanical functions. I mean, systems engineering is an approach to combine all these subsystems and systems together to find out the multidisciplinary dynamic behavior of the whole system as a whole together. So in this example, I mean, I'll be highlighting on electric powertrain performance. Basically, we need to start with the system's logical circuit definition. So that is the first and foremost thing that we need to do. So we have a CATIA systems architecture definition to take care of the logical circuit definition. So the main advantages of using this particular RFLP approach is that you'll be able to find out the complete dynamic behavior of the whole system, and you'll also be able to you'll also be able to check the vehicle range, charging access vehicle range. You can also do the trade-off studies, do your design of experiments, find out the optimal values, and see how best is the 100% performance coming out of these optimal values. So in this example, I'm going to highlight how this electric powertrain as a system is prepared from the RFLP approach, and then I will also highlight how this particular role will help you in terms of understanding the vehicle ranges and the charging time along with the accelerations. So if you look at the complete vehicle systems architecture definition, so this is how it is highlighted here. Yeah, on the left side you see the RFLP approach definition and on the tree structure here. So this is the overall vehicle systems architecture which we are going to define in terms of systems and subsystems. So in this case, we have collisions avoidance system, under which we also have defined autonomous energy braking systems, emergency braking systems, and also the ADAS architecture. So first we need to define the vehicle systems architecture first, and then on top of that we need to define each and every subsystem level, and under those subsystems again we will enter into the electric powertrain. So this is how the architecture is defined in terms of 2D symbols, again getting associated with the 3D physical models. So here we are combining the functional definition and also the logical circuit definition and the physical modeling. So typically the vehicle systems architecture is defined in this way, along with all its relations and impacts between the systems and subsystems. So this is how first systems architecture is defined in terms of 2D symbols with the help of CATIA systems architecture designer role which is available. And then once we define this, we'll be able to bring the libraries which are already inbuilt. That is, it could be cooling system library, or it could be electric powertrain library, or any other subsystem libraries we can bring in through DIMOLA definition. So DIMOLA is the language, systems engineering language, through which we will be able to build the circuits step by step. We also have ready-made built-in sub-assemblies in libraries in terms of 2D circuits. So this is what I wanted to highlight first with respect to vehicle systems architecture first. Then I will move into electric powertrain system and its performance. So in this example, I'll be highlighting on how the electric powertrain performance is measured, and also how the trade-off analysis studies are done using this particular role called electric powertrain systems engineer. So as you see on the left side, we are first defining all the parameters, so which is very, very critical here. So when you look at the marketing parameters, or the and also the technical parameters, all are highlighted in the RFLP tree structure. So here we have a battery cooling system, and then under the logical circuit definition, we can see the complete 2D symbolic representation, including electric powertrain, chassis, and the battery pack module. So all the three are highlighted here, and how it is linked with the main circuit. So a battery operated electric vehicle circuit is already there as a part of the library. So we bring in that library and we look at the parameters. So we can adjust these parameters by looking into the tabs, and then we can set those parameters against the standards. Again, you have standards like 26262 IS4 standards, or it could be European standards, NCAP standards. We can always set our parameters against these standards and go for the simulation. So now you see when we go for this the graphic pattern which has come out of this simulation of this 2D circuit. This is how we simulate the 2D circuit definition, and we can arrive at the maximum torque definition, and also the nominal motor speed, and also what is the motor speed at the maximum vehicle speed level, again with the different criteria: acceleration from 0 to 100 kilometers per hour, or 80 to 120 kilometers per hour. So based on this specific settings, we'll be able to arrive at the values, optimal values, by simulating this 2D circuit. So now the libraries are readily available under CATIA systems dynamic behavior modeling libraries. I mean, you will be able to bring those libraries with the subassemblies and 2D circuit definitions, and then you will be able to first complete the logical circuit definition, validate that, and run these parameters for design of experiments to find out the optimal values. So we can do the complete logical circuit design, then testing, validation, and simulation using this CATIA systems approach. So again, we can also set the charging time with respect to vehicle range. Those calculations also we can do. We can run through multiple design of experiments to find out the optimal values, and we can also say like how many seconds time is needed. Again, with respect to multiple models, here we have thermal model, electrical model, and also the aging model, battery aging model. So we need to look at these models and then set our parameters and run the design of experiments. So this will result in the optimal value calculations in this way, resulting in the graphical patterns. So you have the charging time, and also highlighting about the battery pack as a whole. So in this we can also set if I'm increasing the width of the the battery pack system where it is sitting on the chassis. If I'm increasing the width on the chassis, if it is accommodating few more cells, so what is the impact on the overall system? That also can be calculated in this fashion. So the most important part is that this is a well-developed language, what we call DIMOLA, which is available as a part of our electric powertrain systems engineer roles, which you can always access and then create these circuits. Once it is circuit definition is complete, you will be able to validate, simulate, and also find out the optimal results through design of experiments. So this is how the systems engineering is going to help you in terms of modeling the complete electric powertrain, and also you can gauge its performance from time to time, varying the multiple parameters against the specific standards. It could be ISO standards 26262 or Europe NCAP standards. We can adhere to those standards and we can measure these values against and find out the right performance. So this is how we simulate the complete electric powertrain. And not only this, there are many other libraries also available with respect to EV segment. So as I said, we can also simulate the complete battery pack, even from the vehicle systems architecture perspective. We can also look at the ADAS, AEBS, that is autonomous emergency braking systems, collision avoidance systems. All these circuits we can definitely validate them and also look for the best of performance through these RFLP definitions. So this is from my end. Sanjeev, you can move forward.
Overall, if you look into this kind of when you are into this kind of connected and the collaborative environment, environment. So it is always it enhances your cross teamwork. So you can always you can remove your silos. So thereby connecting all your stakeholders into a single in a single alignment. So thereby focusing on each and every department will be knowing what is the update happening in the each and every department. So it is always good to be connected within the stakeholders to complete a project at a given time. So that by collaborating with these kind of internal teams, you can always reduce the time to market of your product. So thereby optimizing the performance and efficiency across the multiple disciplines. As we mentioned before, you can easily do the multiphysics simulations for your cell level, or when it comes to the module and the pack level, so you can drastically reduce your time in getting assessing the characterizations of your cells and batteries. Okay. So always you can then minimize your risk of the warranty claims of your products. So you can that by you can reflect that in your ROI. So when it comes to the comfort zone, so with this help of the system architectural and along with the vehicle integration systems, you can very well ensure the comfortness of the occupants of your the end users. So, and also you can reduce the development time and the cost of the prototyping. So that by within this kind of single virtual test setup environment, you are combining all these kind of testing. You are doing the testing in within the single environment. So all the kind of 3-point bending test or whatever the mechanical test you are doing. So you can you need not spend much amount of time in the creating the prototypes and investing a lot of amount in test. So rather you can expose more into these kind of virtual tests rather than so that by minimizing the amount of the prototypes. So this brings the confidence in virtual performance assessments of an industry. So that by producing the detecting the flaws of your design at the earlier design stage itself. So that by eliminating the risk at the end of your target date. So this is how 3D Experience Simulia helps a company so to enable their products and engineers to produce an optimized design to the end users.
So I would like to thank the audience for making their time out and turning up for this webinar. I hope this session has been insightful for you. So if you want to further connect with us to discuss more on the battery management system and the powertrain engineering part, you're always welcome to connect with us. Our credentials are displayed on your screen right now. You can always mail us or you can call us as well. So we'll be available and we'll help you in whatever way we can. I would like to thank our industry experts, Mr. Sanjeev and Mr. Shri Kumar sir, for explaining so very well the different parts and capabilities of Simulia with respect to battery management system and the powertrain engineering as well, and how it can be all done in a single unified platform called 3D Experience platform. So thank you, Sanjeev. Thank you, Shri Kumar sir. So please stay tuned for our future webinars. And once again, thank you from us. Thank you.